Hello everyone, welcome back to our channel Discover Knowledge with Anu. We shall see few more problems based on the topic of system of equations. This is a given question: x plus y minus 2z plus 3w is equal to 0. X minus 2y plus z minus w is equal to 0. 4x plus y minus 5z plus 8w is equals to 0. And 5x minus 7y plus 2z minus w is equals to 0. It is a homogeneous system of equation. First write the matrix of A. Here write the first coefficient of x as 1, coefficient of y 1, coefficient of z minus 2 and coefficient of w is 3. Similarly write this matrix 1 minus 2, 1 minus 1, 4, 1 minus 5, 8 and 5 minus 7, 2 minus 1. This is a matrix A, coefficient matrix. Write the variable matrix x is equals to, here we have 4 variables, that is x, y, z and w. Write these variables in this matrix x, y, z and w. And at 0 is equals to, this is a 0, 0, 0, 0, or you can tell it as b. And we have the format of x is equals to, ax is equals to 0, since b is equals to 0. Actual equation is ax is equals to b. So for this, it is a b is a constant for homogeneous system of equation. Then b we can write it as o, as o is a 0 matrix. Now reduce this matrix into echelon form in order to find its rank. Reduce into echelon form. Then we apply the row operations. 1, 1 minus 2, 3. This is a diagonal. We have to make this all elements as 0. I am applying the row operations as R2 implies R2 minus R1 to make this element as 0, and R3 implies R3 minus 4R1 to make this element as 0, and R4 implies R4 minus 5R1 to make this element as 0. Now R2 minus R1, 1 minus 1, 0, minus 2 minus 1, that is minus 3, 1 minus of minus 2, 3, minus 1 minus 3, minus 4. And applying the R3 operation, R3 minus 4R1, 4 minus 4 into 1, 0, 1 minus 4 into 1, that is minus 3, minus 5 minus of 4 into minus 2, that is 3, and 8 minus 4 into 3, that is minus 4. Next applying the row operation R4 as R4 minus 5 into R1, then 5 minus 5 into 1 is 0, minus 7 minus 5 into 1, minus 12, and 2 minus 5 into minus 2, that is 12, and minus 1 minus 5 into 3, that is minus 16. Now we have to make these two elements as 0 at first. Applying the row operation from R3 to R2 as R3 minus R2 to make this element as 0, and applying the row operation from R4 to R2 to make this element as 0. Row operation follows as R4 implies R4 minus 4R2. Then this matrix becomes 1, 1 minus 2, 3, 0 minus 3, 3 minus 4, 0, minus 3 minus of minus 3, 0, 3 minus 3, 0, minus 4 minus of minus 4 is 0, and here minus 12 minus 4 into minus 3, that is 0, and 12 minus 4 into 3, 0, minus 16 minus 4 of minus 4, that is 0. Okay, now it is, so this is a diagonal, all these elements are 0. Now it is in echelon form. Therefore rank of A is 2, as these two are 0 rows, these two are 0 rows, and these two are non-zero rows. Okay, there, that's what the rank of this matrix is 2, that is equal to R, and R is equals to 2, and next whereas n is equals to 4, because n is the number of variables, and those number of variables are x, y, z and w are the variables. So that's why n is equals to 4. And if we observe here, the condition as R n less than R, nothing but n is greater than R, nothing but R less than n. It follows this condition R less than n, whereas R is equals to 2 and n is equals to 4. We got R less than n, that is 2 less than 4. Then the given system of equation has non-trivial solution or infinite number of solutions. So in this case, n minus r variables has to assign as a arbitrary constants. So in this n minus r, that is equal to 4 minus 2, that is 2. Since n is equals to 4 and r is equals to 2. So in this case, two variables we have to assign. Two variables has to be assigned as a arbitrary constants. Now write the equations from this echelon form of matrix as x plus y minus 2z plus 3w is equal to 0, and 0x minus 3y plus 3z minus 4w is equal to 0. So equations from the echelon form matrix are x plus y minus 2z plus 3w is equal to 0, and minus 3y plus 3z minus 4w is equal to 0. Let this equation be as 1 and let this be equation as 2. Now let the two constants, we have assigned two variables, let those constants be as k1 and k2. One is k1 and another one is k2. So I am taking that variables, let z is equals to k1 and w is equal to k2. Okay, now put the values of z and w in equation 2. Put values of z and w in equation 2. Then we get the equation as minus 3y plus, we are substituting this z and w in this equation because here is only one variable and these two variables we substitute this constant, then it will be very easy to get the value of y. Now 3k1 minus 4k2 is equal to 0. Then minus 3y is equals to, send this plus 3k1 to right hand side, it becomes minus 3k1, and send this minus 4k2 to right side, it becomes 4k2. Then y is equals to minus 3k1 plus 4k2 divided by minus 3. Now y is equals to k1 minus 4 by 3 k2. It means I am taking this denominator separately for first term and second term. Minus 3k1 by minus 3 plus 4k2 by minus 3. Then this minus 3k by 1, k by minus 3, it becomes k1 minus 4k2 by 2. So this is a value of y. Now substitute this z, w and y in equation 1 to get the value of x. This is the equation 1. Substitute those values. Then we get it as x plus y value, we got it as k1 minus 4 by 3 k2 minus 2 into z, we have taken it as k1 plus 3, we have taken w as k2, and that is equal to 0. We get it as x minus k1 plus 5 by 3 k2 is equal to 0. So from this k1 minus 2k1, we get it as minus k1, and minus 4 by 3 k2 plus 3 k2, we get it as 5 by 3 k2. Now x is equals to, send these two terms to right hand side, then minus k1 becomes k1 and plus 5 by 3 k2 becomes minus 5 by 3 k2. So this is the value of x. Now at last the solutions are, it means the values of x, y, z and w are, x is equals to k1 minus 5 by 3 k2 and y is equals to k1 minus 4 by 3 k2, z is equal to k1 and w equal to k2. So this is the final answer which we are getting. We will see another problem based on the same topic. This is somewhat different question compared to other questions which I have explained in previous problems. Here you can see there are 4 variables x, y, z and w. But there are only 3 equations here. It means we will get 3 by 4 matrix. It is a homogeneous system and you can write the matrix as A 4 2 1 3 and 6 3 4 7, and here coefficient of x is 2, coefficient of y is 1, and we don't have here z variable, so take it as 0, and the coefficient of w is 1. This is a coefficient matrix, and variable matrix as x is equals to, there are 1 2 3 4 variables x, y, z and w, and constant matrix that is 0 or that is b or o, that is equal to 0 0 0, because only 3 equations. This is of the form Ax is equals to 0. Now reduce this matrix into echelon form to find its rank. So this is the diagonal, and reduce into echelon form. Row operation follows as R2 implies 2R2 minus 3R1 to make this element as 0, and another operation R3 implies 2R3 minus R1 to make this element as 0. Then 2 into 6 minus 3 into 4, that is 0. 2 into 3 minus 3 into 2, that is 0. 2 into 4 minus 3 into 1, 5, and 2 into 7 minus 3 into 3, which is 5. And applying the row operation R3 to make this element 0, follows as 2 into 2 minus 4, 0, 2 into 1 minus 2, 0, and 0 minus 1, and 2 into 0 minus 1, that is minus 1, and 2 into 1 minus 3, that is minus 1. Now this is in echelon form, but we can apply one more operation from R3 to R2 to make this element 0. R3 implies 5R3 plus R2, 4213, 0055, 5 into minus 1 plus 5, that is 0, and here also you will get it as same 0. So just we are making it as 0 to make our calculation very easy. And now from here, rank of the matrix A, that is equal to 2. As these two are non-zero rows, this is a 0 row, it does not come under the consideration in finding the rank. Rank of row of A is equals to 2, that is R, and here R is equals to 2. Therefore n is equals to 4, because where n is the number of variables, here variables are x, y, z and w are variables. Now here r less than n, it means 2 less than 4. So in this case we will assign n minus r variables. It is a non-trivial solution, or it has infinite number of solutions. So in this case we will assign n minus r variables, where n is 4 and r is 2. 4 minus 2 is equals to 2. So we will assign n variables as arbitrary constants. Write the equations from the echelon form. Are 4x plus 2y plus z plus 3w equal to 0, and from this is x coefficient, y coefficient 0 0, and next this is z, so 5z plus 5w equal to 0. So we have assigned two constants as n minus r variables. 4 minus 2 is equal to 2, so two variables has to be assigned. I am taking those two constants as, let those two constants be k1 and k2. Let z equals to k1 and y is equals to k2, because I am not taking w is equal to k2. If I take w equal to k2, then we will substitute, when we will substitute those two values in this, then here it doesn't have any other variables like x and y, we don't get anything. But we have to take here one variable from this equation and another variable from this equation. If we take z and w, then our calculation will be easy, and if we take z and w, we cannot get this equation. So I am taking z as k1 and y as k2. Now if I substitute this in this, let this equation be first and let this equation be second. If I substitute z value in this, we get the value of w, and with that z, w and y values, when we substitute in equation 1, we get the value of x. Now if I substitute this value in equation 2, we get it as 5k1 plus 5w equal to 0, and 5w equals to minus 5k1, then w is equals to minus 5k1 by 5, that is equal to minus k1. So we got the value of w as minus k1. and this is z equals to k1 and y is equals to k2. Now substitute this z, y and w values in equation 1 in order to get the value of x. Then 4x plus 2 into k2 plus k1 plus 3 into minus k1, that is equal to 0. Then we get 4x plus 2k2 plus k1 minus 3k1 is equal to 0. Then 4x minus 3k1 plus k1, that is minus 2k1, and plus 2k2 is equal to 0. Then 4x is equals to, send these two terms to the right hand side, then this becomes minus 2k1. If it goes to RHS, it becomes 2k1, and plus 2k2 if it goes to RHS side, it becomes minus 2k2. Then 4x is equals to, and I am sending this 4 to the right hand side, it becomes 2k1 minus 2k2 by 4. From here numerator I am taking as common, then k1 minus k2 by 4, 2 1s are 2, 2 2s are 4. Then x is equals to k1 minus k2 by 2. This is the value of x. So therefore the solutions are, it means the values of x, y, z and w are, x is equals to k1 minus k2 by 2, and y is equals to k2, z equal to k1, and w is equals to minus k1. So these are the solutions which we got. Thank you.